This question comes from Daniel, who asks, what if the sun blinked off for 1 second every minute? My question for Daniel, who gave the sun a light switch. Because 1 second doesn't sound like much. You blink slower than that. But when the thing blinking is the source of all light and energy for your planet, 1 second starts to matter a lot more. Let's start simple. Every minute for 1 second, the sun just turns off. No warning, no fade, just gone, and then back again. At first you might not even notice. During the day it would feel like a strange flicker, a brief dimming, like a cloud passed over too fast to make sense. If you were outside, you'd probably pause for a second and look up, wondering if your eyes just glitched. But then it happens again, and again, once every minute, and now your brain starts paying attention. After a few cycles, it becomes impossible to ignore. Lights flicker in rhythm with the sky, shadows snap in and out of existence. The world develops a strange heartbeat. 59 seconds of normal, 1 second of not. Now let's talk about what actually happens during that 1 second. Because when the sun turns off, Earth doesn't instantly go dark. Light takes about 8 minutes to travel from the sun to Earth. So when the sun blinks, we don't see it immediately. We see it 8 minutes later. Which means once the blinking starts, Earth enters a loop. Every minute, like clockwork, sunlight disappears for 1 second. And it does this forever, or at least as long as the blinking continues. Now 1 second of darkness might not seem dangerous, but it starts adding up. There are 1,440 minutes in a day, which means the sun would be off for 1,440 seconds total. That's 24 minutes of lost sunlight every single day, not all at once, but scattered, like tiny cuts. At first the planet shrugs it off. Temperatures don't crash overnight. The atmosphere holds heat. The oceans buffer the changes. But the rhythm, that's the real problem. Because ecosystems don't just rely on sunlight, they rely on consistency. Plants expect continuous light for photosynthesis. Now every minute their energy input gets interrupted. It's like trying to charge your phone, but someone keeps unplugging it every 60 seconds. Growth slows, efficiency drops, crops start producing slightly less, not dramatically, just enough to be noticeable over time. Now stretch that over weeks, then months, then years. Agriculture becomes less predictable. Some plants adapt, some don't. Food systems start to wobble. And then there's the human side, because this isn't just happening in fields, it's happening everywhere. Imagine driving at highway speed. Every minute, for 1 second, the entire world goes dark. No sunlight, no visibility. If it's daytime, it's manageable. If it's near dusk or dawn, it's not. Airplanes, ships, traffic systems, all forced to adapt to a world that blinks. You'd see new technologies emerge, backup lighting systems, predictive systems that anticipate the blink, entire industries built around that one missing second. But then we move higher, up into the atmosphere, because the sun doesn't just provide light, it provides energy that drives weather. Every minute, that energy supply cuts out briefly. It's small, but it's constant, and constant interruptions have a way of adding up. Wind patterns begin to shift slightly, temperature gradients fluctuate. Over long periods, climate models would start showing subtle instability. Nothing catastrophic at first, just off. Now let's go further. Because space doesn't like interruptions either. Solar radiation isn't just light, it includes charged particles that interact with Earth's magnetic field. If the sun is blinking, that stream is pulsing. On, off, on, off. Auroras would become more erratic. Satellites would experience repeated thermal cycling. Heating, cooling, heating, cooling. Over time, materials fatigue, systems degrade. Space infrastructure starts aging faster than it should. But here's where things get more interesting. Because we've been assuming the sun turns off and on cleanly, like a switch. But stars aren't light bulbs. They are massive nuclear reactors. If the sun's output is fluctuating every minute, something deep inside it is changing. And that's not normal. That's not even slightly normal. For the sun to blink, its fusion process would have to be disrupted. And fusion doesn't like being interrupted. If the core reactions are stuttering, starting and stopping, that suggests instability. And instability in a star is not a surface problem. It's a core problem. Now, maybe, just maybe, the sun manages to keep this rhythm stable, blinking forever, a cosmic metronome. Annoying but survivable. But if that rhythm slips, if the timing drifts, if the off period becomes longer, 2 seconds, 5 seconds, 10, now we're not talking about flickers anymore. We're talking about real energy loss, real cooling, real consequences. And eventually the question stops being, can we adapt? And starts becoming, how long do we have? Because the sun is not supposed to blink. Not once. Not ever. So if it does, that 1 second of darkness every minute might not be the problem. It might be the warning, but something at the heart of the system we depend on the most has started to fail. And in a universe where stars don't get second chances, you probably don't get many either.